the Phi correlation also has some biases. What happens when we have two diseases that are maximally correlated? When two diseases are maximally correlated, we can say that the overlap between them is maximum, and then we can assume that C12 is equal P2. Okay? So in that case, Phi reduces to P2 times n minus P1 divided by the square root of n minus P1, n minus P2, P1, P2. And you can see that you can simplify some terms here. So Phi, in that case, becomes the square root of P2, n minus P1, divided by the square root of P1, n minus P2. This is the case of maximum correlation. Phi looks like that. Now, let's take the case in which P1 equals P2. The two diseases have the same prevalence and they have complete overlap. Then, because this is symmetric in P1 and P2, this implies that Phi is equal to 1. So, that looks good. You know, it looks that when two diseases have complete overlap between them, the correlation is 1. Now, what happens though when instead of having maximum correlation, we have another case in which P2 is much smaller than P1 and P1 is much smaller than N. We have a very little prevalent disease, a disease of medium prevalence, and a very big population. In that case, we can neglect N minus P1 and convert it to N, and N minus P2, we can also say that it goes like N, and this is going to go like the square root of P2 over P1. So the maximum value that Phi can take is P2 over P1 on the square root, but we know that P2 is much smaller than P1. So therefore, the maximum value that Phi can take is smaller than 1, and it could be quite a small number. So therefore, Phi has a bias to have smaller values for diseases that, when comparing diseases that have very different prevalences.